impulse or an action potential is the electric signal that pass along the dendrites. It is the overall physiological changes that occur in a neuron by any chemical, mechanical or electrical disturbances which are caused by any stimulus. So the propagation of the nerve impulse through the axon or the synapse or any other neuromuscular junction, it is known as nerve impulse conduction. In this video, we will learn about the transmission of nerve impulse. Step 1. Generation of the impulse. A neuron at the resting phase, it is electrically charged. Let's draw a neuron out here. So a neuron at the resting phase. This is the resting phase where it is electrically charged, but it is not conducting. Why not conducting? Because any stimulus has been received. There is no overall changes that is occurring in the neuron. So that's why there is it's not conducting. You can see the charge out here. So what is here? This is extracellular fluid, and this is our neuroplasm, or we can also call it as a exoplasm. And what is this we are showing is a axon. So outside the extracellular fluid, this is an extracellular fluid. This is electropositive as compared to the neuroplasm. We can see here the plus charge, and this is a minus charge, negative charge. So extracellular fluid outside the neuron, it is electropositive as compared to the neuroplasm of the resting neuron. So which phase is this? This phase we will call as resting phase. Now why this extracellular fluid is positive? It is electropositive. Why? It is because of the presence of sodium ions. Because there are sodium ions present, and neuroplasm is electronegative due to the presence of potassium ions. Right? Potassium ions, it's not clear. I'll write it with another pen. Okay. Potassium ions. So the extracellular fluid is positive because of the presence of positive sodium ions and also the positive protein. And the neuroplasm is compared to the extracellular fluid, it is electronegative due to the presence of potassium ions and the negative protein. We can also mention here the negative protein is present in neuroplasm and the positive protein is present in the extracellular fluid. Now to your surprise is ECF or the extracellular fluid, it has 16 times higher concentration of sodium ions than it is inside the neuron. So 16 times higher concentration of sodium ions, and inside the neuron it is 25 times higher potassium ion concentration. Got it? So there is 16 times higher concentration of sodium in extracellular fluid and 25 times potassium ions higher in the neuroplasm than the outside. It is compared to inside and outside. So when we are comparing sodium ions outside, we are comparing it with the neuroplasm. And when we are comparing 25 times potassium ions, it is as compared to the ECF. Now there are, in any of the axon, there are sodium channels. There are sodium channels and the potassium channels. In any of the axon, there will be sodium channels and the potassium channels. And along with that, I'll mention it here. The sodium ion channels will be there. The potassium ion channels will be there. Then there is also available the sodium potassium pump. Now all these axons, they act at a certain voltage. What is that voltage? It is 70 millivolt. What is that voltage? It is minus 70 millivolt. This potential difference is known as a resting potential. This potential difference is known as a resting potential. And such resting membrane is known as in the state of polarization, or we can say it is the polarized state. Why? Because it is having polarized state, because it is having electropositive in extracellular fluid and electronegative in the neuroplasm. And resting potential, this is the potential which is about minus 70 MV. Now nothing is happening. There are no changes happening in the neuron as I told you earlier. Right. Now when at the resting potential, the membrane of the neuron is more permeable to potassium ions. So at the resting potential, it is more permeable to potassium ions. More permeable to potassium ions. So what will happen? When this resting membrane is more, it is more permeable to potassium ions. So what will happen? The potassium ions which are inside the neuroplasm, they can move out. Right? They can leave the neuron faster than the sodium ions which are entering the neuron, because at the resting potential the membrane of neuron is more permeable to potassium ions, therefore more entry of potassium, more exit of potassium ions from the neuroplasm will be there rather than the entry of the sodium ions inside the neuron. So as I told you, such state of resting neuron is called the polarized state, and at this point the neuron is negatively charged. The neuron is negatively charged. I hope I am clear with it. In each neuron, there are few activation gates in the membrane. I'll draw one neuron out here. So let us see here. These are the sodium channels. Right, the same way we will be having the potassium channels as well. If I draw it here, I can show you one potassium channel as well. So these both are same. These are the channels in the membrane. Now in these membranes, what is important? There are few activation gate. Now for this sodium ions, this is the activation gate. That means the entry of sodium ions will be through this gate. And here the second one is the which is from which the entry can be limited or the exit can be there. This is known as a deactivation gate. Activation gate, or more appropriately I can call it as the inactivation gate. Right, this is the axon we have shown in the resting state. Right, this is the activation gate and this is the inactivation gate. When stimulus is received, now upon receiving the stimulus, what will happen? Upon receiving the stimulus, these activation gates which were closed earlier, this will open. The activation gates will open. Activation gates open. Right. Now when the gates will open, then what will happen? Let me show you one neuron membrane here. This is a membrane. I'll just show one layer, one side of this neuron membrane. So outside we are having the electropositive charge, right? And inside we are having the negative charge. Now when the activation gates are open, what will happen? These sodium ions which are present in the extracellular fluid will move out. Why? Because these activation gates are open. When the stimulus is received at around, this happens at around minus 55 millivoltage. So this much volt is required for the sodium ion channels to open. So once the channels are open, the sodium ions will start moving inside the neuroplasm. Now there will be more concentration of sodium ions inside, right? So now can we call it that it is polarized? Tell me, is it still polarized? No, we cannot call it as polarized, but it is the depolarized state or the reverse polarized state. Now the diffusion of sodium ions increases 10 times The diffusion increases 10 times from outside to inside. Earlier it was 16 times concentration was higher.